Hello everyone. My name is Chris Toval. In this video we will talk about combination with repetition. But before that, please leave a like, comment and subscribe this channel.
Now, let's get to the video. You may asking, what is the meaning of combination with repetition? Well, let me answer that question. A combination with repetition of k object from n is a way of selecting a k object from a list of n. The selection rules are: 1. The order of selection does not matter. The same objects selected in different order are regarded as the same combination. 2. Each subject can be selected more than once.
Thus, the difference between simple combinations and combinations with repetition is that objects can be selected only once in the former, while they can be selected more than once in the latter. The following subsections give a slightly more formal definition of combination with repetition and deal with the problem of counting the number of possible combinations with repetition. A more rigorous definition of combination with repetition involves the concept of multiset, which is a generalization of the notion of set. See the lecture entitled Set Theory. Roughly speaking, the difference between a multiset and a set is the following: the same object is allowed to appear more than once in the list of members of a multiset, while the same object A, B, C, A is allowed to appear only once in the list of members of an ordinary set. Thus, for example, the collection of objects is a valid multiset, but not a valid set because the letter appears more than once. Like sets, multisets are unordered collections of objects, i.e. the order in which the elements of a multiset are listed does not matter. Let A1, A2, An be n objects. A combination with repetition of k objects from the n objects A1, A2, An is one of the possible ways to form a multiset containing k objects taken from the set A1, An. Example: consider 3 objects A1, A2 and A3. There are 6 possible combinations with repetition of 2 objects from A1, A2 and A3, that is, 6 possible ways to choose 2 objects from this set of 3, allowing for repetitions. Other combinations are not possible, because, for example, A2, A1 is the same as A1, A2. Denote by C, nk the number of possible combinations with repetition of k objects from n. How much is C, nk in general? In other words, how do we count the number of possible combinations with repetition of k objects from n? To answer this question, we need to use a slightly unusual procedure, which is introduced by the next example. Example: we need to order 2 scoops of ice cream, choosing among 4 flavors: chocolate, pistachio, strawberry and vanilla. It is possible to order 2 scoops of the same flavor. How many different combinations can we order? The number of different combinations we can order is equal to the number of possible combinations with repetition of 2 objects from 4. Let us represent an order as a string of crosses x and vertical bars L, where a vertical bar delimits 2 adjacent flavors and a cross denotes a scoop of a given flavor. For example, where the first vertical bar, the leftmost one, delimits chocolate and pistachio, the second one delimits pistachio and strawberry, and the third one delimits strawberry and vanilla. Each string contains 3 vertical bars, 1 less than the number of flavors, and 2 crosses, 1 for each scoop. Therefore, each string contains a total of 5 symbols. Making an order is equivalent to choosing which 2 of the 5 symbols will be a cross, the remaining will be vertical bars. So, to make an order, we need to choose 2 objects from 5. The number of possible ways to choose 2 objects from 5 is equal to the number of possible combinations without repetition of 2 objects from 5. Therefore, there are different orders we can make. In general, choosing k objects from n with repetition is equivalent to writing a string with n plus k-1 symbols, of which are vertical bars and k are crosses. In turn, this is equivalent to choose the positions in the string, among the available n plus k-1, that will contain a cross, the remaining ones will contain vertical bars. But choosing k positions from n plus k-1 is like choosing a combination without repetition of k objects from n plus k-1. Therefore, the number of possible combinations with repetition is. The number of possible combinations with repetition is often denoted by and is called the multiset coefficient. Example: the number of possible combinations with repetition of 3 objects from 5 is